All right, in previous videos, we've looked at how many signals there should be in an NMR spectrum. We've looked at where they should appear on the x-axis, and now we're going to talk about signal intensity, or the area under each of the peaks. So the area under the peak, or the integration, tells us about how many protons are giving rise to that signal. And so sometimes they'll give us the values as integration values, they'll give us numbers, or sometimes there will be these step functions that we then have to use to determine the integration values. Right, but basically, the higher the step value, the greater the integration value. Now, usually what we do is set one of the peaks to 1. And so whichever peak has the smallest integration value, we just divide the other peaks by that value, right? So 27 divided by 27 is obviously going to give us 1, and then 40.2 divided by 27 gives us 1.48, 1, and 1.56, right? And so now these are the relative numbers of hydrogen atoms compared to the smallest peaks. Now, we don't like having half of a proton, so when we get fractions like this, what we're going to do is multiply each of these by 2, right? And so this corresponds to 2 protons, 3 protons, 2 protons, and 3 protons. Now, the integrations tell us about the relative number of hydrogen atoms. It doesn't tell us the actual number of protons. And so the symmetry of the molecules can often affect the integrations, right? If I consider butane here, I've got CH3s, CH2s, another CH3, right? And the 2 methyl groups are chemically equivalent, and the 2 CH2s are also chemically equivalent. And so we're going to have 2 signals, right? But rather than coming out as 6-4, right? Because the integrations don't know that, right? The best they're going to be able to tell us is that the ratio is 3-2. And so to determine the exact number of hydrogens giving rise to each signal, unless I know the chemical formula, all we're going to know is the relative number of hydrogen atoms that each peak contains. All right, so if we do a couple examples, they've told us the chemical formula, and we want to know how many hydrogens give rise to each one of these peaks, and they've given us the integration values. Right, so what we want to do is divide each one of the integration values by the smallest one. So I'm going to divide them all by 17, right? And so that's going to give me a value of 1, and then 87.1 gives me 5.1. That's going to be 1 again, and then the 51.1 gives me 3. And so this may be the relative number, or it may be the actual number, right? And so we have to see, right? If we add up each of these numbers, if it gives us 10, then we're just done, right? And so 1 plus 5, 6, 7, 8, 9, 10, right? So not only are these the relative number of hydrogen atoms that give rise to each peak, it is in fact the actual number of hydrogen atoms that give rise to this peak, right? When we add up all these values, if we get 10, then we're done. Let's do an example where that does. All right, now we have 2 peaks, so we'll do the same thing. We'll divide both numbers by 32.5, and when I do that, I get 1 and 1.5. Of course, we don't like fractions of protons, right? So to get rid of the half, we'll multiply them both by 2, right? So I think what I have for this peak is a relative number of 2. For this peak, I have a relative number of 3. Right, now I compare that to the formula, right? This is H10, right? I've only accounted for 5 of the protons. So what we can do is take the total number that we know from the formula, 10, divide that by the sum of the relative numbers, in this case 5, and this will tell me what I have to multiply each relative number by to get the total number. So 2 times 2, that tells me that 4 protons give rise to that peak, and 6 protons give rise to that peak, right? And we can double check, right? 4, 6, 10, I've accounted for all my protons. All right, one last example. So they've given us the formula again and the integration values. I'll divide everything by 16.1. When I do, that's going to give me 1, 2, and 3. I don't have any fractions, so I'm good on that front. But now when I add up my relative numbers, I get 6, right? In fact, I have 12 protons, so the total number of protons I know I have is 12. When I add up my relative numbers, I get 6, so I need twice the relative numbers. So 2 times 1, 2 protons give rise to that signal, 4 protons give rise to that signal, and 6 protons give rise to that signal. And again, I can double check. 6, 10, no, I'm sorry, 6, 10, 12, right? And so I think we're good to go.